This video gives a brief overview of how science teachers can use the 5 essential features of inquiry for creating inquiries of their own. It focuses on the first part of this question, what is inquiry itself? And it uses the 5 essential features of inquiry from this book, Inquiry and the National Science Education Standards, which is available free and online. The first essential feature of inquiry is this one given here. And the key here is that engaging scientific questions are the way to start an inquiry. One of the best things you can do here is to reach out to the ideas of science literacy from something like Atlas of Science Literacy or Science for All Americans to determine a topic that you can engage your students in. The challenge here is much of traditional science in America, college prep science, isn't engaging for students because it doesn't answer a question about what they need to know now that will enrich their lives. So inquiry starts when students are engaged in a scientific question, but one that truly is valuable to them because it connects to their life as science literacy does. So as you're writing your inquiry, what's the question that's going to guide the students throughout the whole inquiry? Begin there and begin your lesson with that. The next thing that happens in inquiry is this, essential feature number 2. In essential feature number 2, learners start with evidence. And so that's typically evidence that they collect in a hands-on or a lab outside, but it can also be evidence that you give to them that someone else has collected, especially if it's too expensive or too dangerous for students to collect themselves. So here's the second feature of inquiry. After students are engaged in thinking about a question, then they begin to collect and focus on evidence. Here's the key here. Don't explain to them the science, the answer to the question at this point. Let them get into the evidence themselves. Next, you might think that they need a lecture first, but my experience with teenagers is they typically aren't listening at that point either until they get into real data. So that's the second feature. Start with a question. Get them thinking about that question. Perhaps they even write about the question. Then get them straight into the evidence, either collecting the evidence or examining the evidence that you provide to them and see if this makes sense so that they begin to make initial answers to the question you've raised. Well, that takes learners to essential feature number 3. Here it is. And here, your students begin to answer the question, to develop an explanation that answers the question you've given them from the evidence they've seen. Okay, here's a danger again. This is the point that most of us as science teachers want to explain the answer to the question to the student. We love explaining science, but here we have to hold back because if your students develop their own explanations, they will own those explanations. If we give them the explanation, then it's ours and the students don't own it. So this is typically where students are working in small groups in the groups that they have collected data in, and they're beginning to try to explain the evidence they've seen in front of them in a way that answers the question. Well, you may be wondering, but what if they're wrong? Well, often they are wrong. Often their answers are incomplete or they can get off into the weeds. Good students can actually come up with an incorrect explanation. Well, that's where essential feature 4 comes in. Take a look at it. This is the point when the teacher makes sure that the students are developing explanations that are sound answers, sound scientific answers to the question, answers that fit the evidence. And here the teacher often is the one, it has to be the one that even at times challenges students who have come up with a wrong explanation, going back to the evidence. See if that makes sense. It's not the teacher saying, I'm right and you're wrong. It's the teacher guiding students to see how their explanation doesn't fit the data. So up until this point, students have probably been working individually or in small groups. They've probably answered the initial question individually. That can be done in small groups. Then they've collected data and begun to explain it in small groups. This feature is typically, it's most effective when you come back into a large group. A couple of ways that you can do that are you could have speakers report their group's explanation from the previous step when they're in small groups, and the whole class is listening to the speaker's reports. Another way to do it is if you have whiteboards or something like that, some kind of data display where the groups can display their data and their explanations. That works. Think of it as a scientific conference. Think of it as the different groups in the room explaining, giving their explanation, the other groups listening with you guiding the discussion so that they see which explanation best fits the data. And if none of the students come up with a solid explanation, you as a teacher cobble together bits and pieces so that they see what a solid explanation is. At this point, students should be seeing the scientific idea, the one that, like it says here, ultimately matches accepted science. They should be seeing it, but it may not quite be solid in their head. So this is where this final step, final essential feature comes in. Take a look at it. And here, your students have probably been doing this all along, communicating and justifying their proposed explanations. They've probably written about their answer, the previous thinking. They've talked about it in small groups. You've talked about it in large groups. But often at this point, there's a lot rolling around in the students' heads. And this is a good point to return to individual writing for them to solidify their thinking. One of the best things to do here is simply to have them go back to the question you posed at the beginning. Are you seeing how that question guides everything in an inquiry? And having them write about how their ideas have changed. You could simply say, how have your ideas changed about the answer to the question I posed as we've gone through today's lab and discussion? And usually as they are writing about how their ideas have changed, that actual writing about it solidifies their understanding. And you could call on them after they've written, and this writing process may only take 2 or 3 minutes, but you could call on some of them to read their responses at the end, and that's your final check, your final formative assessment to make sure that they really have come up with those solid explanations. So, 5 essential features of inquiry, and a quick walk through what they are and how they can be implemented in your classroom, how you can think about creating an inquiry based on those 5 essential features.